Okay, so here is our main perceptron algorithm. Instead of going through this description line by line, let's use a diagram to explain this. So suppose there are two features, x1 and x2, and suppose our perceptron is w1 x1 plus w2 x2 is larger than or equal to 0. So in particular, we're assuming there are no bias terms, so every line would pass through the origin. So let's assume there are some training data that's labeled 0 and other training data that are labeled 1. So the first step is randomly initialize a weight vector w. So suppose it's something like this, w. And what this w does is it divides this plane into two halves separated by this line w transpose x equal to 0. So here w1 is less than 0, w2 is less than 0. So let's try a point. So let's try this. This point has x1 less than 0, x2 also less than 0. So if you multiply them together like this, will be plus and plus. So the whole thing will be larger than or equal to 0. And when it's larger than or equal to 0, it's labeled 1. So points on this side will be labeled 1, and the other ones will be labeled 0. So given the training data points, this one is labeled incorrectly, and this one is labeled incorrectly. So let's pick one. Let's pick this one and see how to use this to update the W. So if we go back, the actual Y is 1, the predicted Y is 0. So the algorithm says increase the weights by X. So let's go back. It says updates this W to W prime by adding X. So this vector is X, this vector is W, W plus X is this point, so this is W prime. Let's use a different color to draw it more clearly. This vector is W prime. And the line corresponding to this will be a line like this that's perpendicular to this vector. So this is W prime X equal to 0. And if you try our method here, this side will be classified 1, this side will be classified 0, and suddenly everything is classified correctly. So of course, this is just by accident. So this particular example turns out that if you update according to one example, the whole thing becomes correct. But in reality, you do need to repeat for all data points, and you may need to repeat many times for all data points until the thing converges. And converge means everything gets classified correctly. So another thing to be careful is updating from this line to this line seems too much. So sometimes we don't want to update all the way. So sometimes we update a small fraction of this x. So it's updated by a small amount. So this line goes from this to this instead of from this all the way to that. So we call this constant fraction the learning rate. So we basically multiply this x by some small alpha less than not 0, less than 1, bigger than 0 every time. So to conclude, we are given the instances, the training data set. We start by initialize the random weights, and then we classify a particular points x, and then if the classification is correct, we update. I mean, if the if it's incorrect, we update. So if it's correct, it means it's either both 0 or both 1. So this whole thing will be 0, so nothing gets updated. So if it's incorrect, then either it's 1 minus 0, which is 1, then it means it's minus alpha xi, or if it's 0, 1, then this is negative, multiplied by this negative sign will be plus alpha xi. So for the bias term, remember this thing plus bias is basically like if you have a longer vector W transpose B multiplied by X and 1. So basically, B is the weight for the feature that's constantly 1. So it's as if it's multiplying by 1. And then here, repeat this for everything in the training data and repeat the whole thing until everything is correct.